Okay, so already I think there are two sessions earlier in this week, right? For week one. Am I audible?
Yes, sir. There have been
Yeah.
two sessions.
Yes, sir, you're audible.
Okay, fine.
Excuse me, just
So basically in the first week, yeah.
I would like to just ask you that yesterday's recorded session is not showing up in the Google Calendar. The YouTube link is not
But
there.
is it?
Yes, sir. It's not showing up, and it wasn't even live streaming yesterday on YouTube.
Oh, okay. So I will inform that. Okay. The session must be recorded. So anyway, I will get it. We will
Okay.
upload it in the portal. No issue for that. Okay. Okay. So what are the concept you have studied in first week? Can someone just tell me that? What are the concept at least are there in the first week? Anyone?
So we have learned about functions,
Hmm.
relations, and sets.
Hmm. Okay. Fine. Can someone tell me what a relation is? Yeah, Rajendra.
A
Subset of a Cartesian. Yeah.
yes,
Rajendra,
sir.
yeah.
Relation is the subset of the Cartesian product of two or more sets, or even on itself.
Okay. So basically in this course, we are mainly talking about binary relations. So there are Cartesian product of two sets only. Okay. And subset of that is basically called relation. Okay. Okay, fine. So let me start with some basic question. So let me share my screen first.
So 4 into 4, 16.
So you're not audible.
Hello.
Am I audible now?
Yes, sir.
Yes, sir.
Yes,
Sir, but no video.
Don't.
Screen
But
is
when I am sharing this, suddenly this mic goes off. I am not getting why that is happening. Let me try again like this. Enter screen maybe. Can you see it now?
Yes, sir.
Okay.
Yes,
Yes,
sir.
sir.
So here I think you can all put your answers, right? There is option for entering your answer. Correct?
1 minute,
sir.
sir. We have to log in.
Yeah. So I think it will give you 30 seconds of time interval so that you can put your answer, type your answer.
So
So
please
the
show the
question was,
question.
so the question was basically, we have a set of cardinality 4. What is the cardinality of A cross A?
Sir, how to join this question answer session?
Yes, sir. I also
Huh.
don't know.
So you can go to this www.menti.com and put this code. That is one way. And another thing, you can directly, so I am copying this link again to the chat box. You can come directly to this. I am putting this in chat box. Yeah, you can go directly to this link to join. Okay. Yeah, so here you can see that I can see what are the options you have typed. Okay, so this was just a test question. So how many of you have already joined this till this point?
Give me a minute, sir.
Join, sir.
Yeah. So I will give you 1 minute to so that some of you can come to this page, and then we can move to the next question, and then we begin our discussion. Okay.
Yes, sir.
Yeah. So
Sir,
let's wait for 1 minute. Yeah.
Upon clicking the link, it's asking you didn't vote in time.
Don't worry about this problem. So from the next problem, we are going to discuss that. And time is not an issue. We can carry out with
Okay.
That. Okay. Yeah. So I will suggest that all of you should have some pen and paper with you. Otherwise, the next problem will be a little bit more in depth. So you have to write down the. Okay.
Yes, sir.
So should we move to the next problem and start the discussion?
Yes, sir.
Yes, sir.
Yes, sir.
Okay. Okay, great.
Yes, sir.
So this is the question from which we are starting our discussion. So we are defining a relation. Okay. Relation is basically binary relation. So a tuple A comma B such that A and B play for the same team. So suppose A and B are two players. They are playing for the same team. Now, which of the following is or are true? So is or are true. So more than one option can be correct. So reflexive, symmetric, transitive, and equivalence. So you have to decide that. Yeah.
Sir, where to enter the answer if I click
I
on
will go to the
option?
next page, then you can select.
Oh,
So first I will
okay,
show the
okay.
question. In the next page, I will show you how you
Oh,
have to
okay.
put the answer.
Okay.
Okay. So is the question clear to everyone?
Yes, sir.
Yes, sir.
Is the relation from one set to itself only?
So it is taking the Cartesian product of all players, maybe. Okay.
So one set
So you
only,
have
na,
set
to
of all
itself.
players. Yeah, A cross A, same set.
Understood, sir.
Okay. So then, which are the following options are true? So there are 4 types of relations, reflexive, symmetric, transitive, and equivalence, right? So I think we can go to the next page. So yeah, here you can put your answer.
Sir, actually option 4 is showing just options. So, but anyways.
But that you understood, no? That is option 4.
Sir, please show the options.
So these are the options. That's why I am saying that take a pen and paper and write down this question when I am showing this. Okay. That will be better.
Sir, the previous slide, please show.
This one is the slide.
No,
Right?
There is no option 4, sir.
Yes.
There is no option 4 there, I think.
Last one is option 4. This one. This is written option. This is option 4. Option 1, 2, 3, and 4. Right? Yeah, many of you have already given the answers, I think.
Oh, you show there. Sir, please move to previous one, please.
Which one?
Previous slide, where the question
The
is.
questions, no?
Yes.
Yeah, this one.
Give me a second. Okay, sir, okay.
Got it, no? Okay, so many of you have given the answer. Now let's discuss on this problem a little bit. So can someone tell me what is reflexive relation?
Yes,
A comma A, B comma B.
No, when all diagonal element present and other can also present other element, then it is
But A
reflexive.
comma A and B comma B, C comma C must be
Yeah,
present.
they must be present, but other can also be present.
Okay. Rajendra, you have raised your hand. Do you want to say something?
You had asked for the answer, so that's why I raised.
Okay. So if I show this page, let's discuss this one. So suppose I am defining a relation on this set A, 1, 2, 3. Okay, and my relation is something like 1, 1, 2, 2, and 1, 2. Is it reflexive?
No, sir.
No, sir.
No.
No, sir.
Why not?
Because 3,
Why?
3 is not
3, is not
present.
present.
Not present.
Exactly. So whatever the elements are here in A, all these should come in a pair, right?
Yes,
All
sir.
this should be related to itself. Now the relation which we are talking about, AB, such that AB play for the same team. Right? So is it reflexive? So first option was reflexive. Is it reflexive?
No.
Yes.
Yes,
No,
sir.
sir.
Yes, sir. Yes, sir.
Yes,
It is.
sir. No,
Yeah.
sir.
Who are saying no? Can you give any argument for that? Why it is not reflexive? So by default, when we are considering about a player, so a player is related to itself, right? Himself or herself, right? Because
Yes, sir.
he or she plays for the same team, basically. So it is by default reflexive. Okay. That means all A comma A must be inside this relation. So let me call it R as it was in the question. So this is reflexive, right?
Yes, sir.
Now, is it symmetric?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
What is the argument for that?
Because if A,
If A,
B
B
play for a same team, then B,
B,
A also play for a
A for
same
same
team.
team.
Okay. Is it transitive?
Yes, sir.
So how it is
Yes,
reflexive?
sir.
Yes, sir.
Sir.
Yes, sir.
Yes, sir. It is.
Okay. Someone was asking how it is symmetric.
Reflexive.
Oh, reflexive.
No.
So any player is related to himself or herself, right? Because he or she plays for the same team while he is or she is playing. So this is by default reflexive. Like A divide, when I am calling saying A divides B. So any number divide itself, right? The same argument is following here. So 2 divides 2. The same type of argument is following here. This is by default. They are related, right? Is it clear?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Okay. So it is transitive also, right? And whenever these three relation is satisfied, then obviously it is an equivalence relation.
Equivalent.
Correct? Okay. Now my question is, so whenever we have an equivalent relation, in lecture you have seen that they form a partition, right?
Yes, sir.
The equivalent classes, right? Can you tell me what are the partitions here? I mean, what partition denotes in this context?
Partition
So
would
how?
be two teams. They would have equal number of players. So it's one group of players would be one.
Basically, partition is suppose, yeah, correct.
It is
Not two teams,
divide.
there can be more than one.
Yes, yes.
So suppose these are collection of all players. So those players who are playing for the same team, then suppose this is team 1, then team 2. So basically, all these players will be divided in different teams, and these teams are basically one equivalent classes, right? And these form a partition. Is this clear to everyone?
Yes, sir.
Can you explain it again?
Okay. So how does partition work? Partition basically, you take one set where all those elements are there, which are related. We put all those elements which are related with each other according to the relation. So in team 1, you will put all those players who are in team 1. So they are playing in the same team. You put take all these players together, call that team 1. Next, suppose you get some other player, and all those players who are related to them put in another team, right? They will be in another part. They will be in another equivalent class, right? That's how these equivalent classes are formed. And each equivalent class is basically
Guys, please mute.
different team here. So noisy.
Please mute, guys.
1 minute.
Excuse me, sir.
Yeah.
Sir, in activity question 1.9, there is last question. There is a option which says a equivalence relation partition a set. Then what does it mean?
That is what I am saying, no? So suppose this is the equivalence relation you are taking, okay? This is the equivalence relation you are taking. Say you name the player. Suppose I am taking, say, Rohit Sharma, okay? I am talking about international cricket team, so let's take Rohit Sharma. Now, my question is, suppose first question, is Virat and Rohit are related? Will Virat comma Rohit or Rohit comma Virat, whatever it is?
Yes, they relate.
Is it inside R?
Yes.
Okay. Yes. Okay. Now, if I take Rohit here in this team 1, if I put Rohit in this team, who else will be there? Who else will be in this set?
Virat.
So, yeah, all those players who are related with Rohit, right? So basically, all those players who are playing in Team India.
Yes,
correct?
yes.
So this is our first equivalent class, which is Team India. So equivalence relation is giving us this equivalent class, right? Is it clear?
So both are same, equivalence relation and equivalence class.
No. Relation is this.
They are not
relation
same.
is this one.
That means it's partition the classes,
Partition
right?
means collection of set, some collection of set, which is dividing the total set in some parts, where each part is an equivalent class. So these are called equivalent classes. So what does this mean? This means take some element from the set and put all those elements which are related to that. As I have taken Rohit, and I have put all those players who are related with Rohit, right? That is the equivalent class containing Rohit. And that is one part of the partition, right? One part of the whole set. Is it clear? That is one equivalent class. So Team India is one equivalent class for this relation. Is it clear?
So in this example, what will be the other class if you want to say, if we have given the example of Rohit Sharma, Virat Kohli, what will be the other class?
Okay, other classes.
For example.
So let's take
actually
Babar
not clear, sir.
Sir, apart from this, can you give a math relation, mathematics
I will come to
relation?
that. I will come to that math relation. This will be easier to understood. If you understand this concept, then math relation will be easier to understand. Okay. Suppose take Babar Azam, right? Pakistan captain, right? So if I put him in team 2, who else will be in that class? All those players who are playing
All
for Pakistan.
Pakistani
All
players.
Pakistani.
Right? So this is the second equivalent class, which is
Yes.
basically Team Pakistan.
So we are talking about world cricket, not only
Exactly.
India.
Sir, you
Not
said
only
that if we consider the whole team, like whole team, then it is said to be equivalence class.
Set of all players.
Yes.
Correct.
Then
They are
and when we consider a single player, then it is a relation, equivalence relation. Is it?
Yeah, world
I
cricket team
have
is a
never
set.
said that. Where the relation is defined over set of all players, all international players, okay, who are playing right now. Okay, I have taken that relation. Now I have how relation is defined. Any two players, I will say they are related with each other if they play for the same team. Okay, so the relation is clear, and you have already said this is an equivalence relation, correct? Because these three checkpoints are done. Right? Now I am talking about equivalent classes. What you will do, you will take one player from the set of all players. Suppose I choose Rohit, and I will see who else are related with Rohit. Which are all the players who are related with Rohit according to this relation. That will give me an equivalent class. So Team India will be one equivalent class, Team Pakistan will be one equivalent class, Team Australia will be one equivalent class, and so on. Is it clear? So this is suppose this, yeah.
So can we take international players from different sports like hockey and tennis like that?
Then the classes will be different, no? Then the
Sir,
total.
here we are taking the class that all international cricket players, right? That is the main,
Right.
Main set, right? On that set, we are defining all these
Right.
relations. Okay.
Right.
Okay. So if you are taking one Indian player, then all the Indian players make one particular class.
Exactly. Now, if you want to see it in mathematical example, so let's consider natural number, set of natural number. Okay. Okay. So I am saying, so I think you have already seen this example. A, B such that, say,
even numbers.
A mod 2.
Even numbers. So
A mod
okay,
2.
let me mod. Basically, I want to construct modulus relation, but I want to say it in little bit different fashion. So this is our set of natural number. Okay. So I have defined some relation for which I am taking all those elements which are, suppose I am dividing those natural number by 4. Okay, dividing by 4. What are the possible remainder there? What are the possible
0, 1, 2, 3. 1, 2, 3.
1, 2, 3.
0, 1, 2, 3.
So 0, 1, 2, and 3. These are the possible 4 remainders, right? Now, if I define this relation, so let me write this relation AB, such that A minus B is congruent to 0 mod 4, right? So I will come back to this relation later, or you can write it like this: A congruent to B mod 4. This is also fine. So basically what I am doing, so if you check, this is an equivalence relation, this you will get.
What is this congruent means, sir?
A minus B, 4 divides A minus B. Okay. If you divide A by 4, B will be the remainder. Is it clear?
Okay,
so
sir.
suppose I take 5. So if I write 5, that's not 4. What will be there? Yeah, 1 minute.
So I beg your pardon.
What will be here?
1.
1.
Yeah. So till this question, anyone has any doubt?
No, sir.
No, sir.
No, sir.
Anyone?
No, sir. No, sir.
Okay. So this is the relation I am talking.
Please explain this again, please.
The last one is
congruent part.
Sir, can you say the code?
The 5 congruent 1 mod 4, I'm not clear.
So I am explaining this. So take any two natural number, okay, A and B. So I am saying A is congruent to B mod 4. That means 4 divides A minus B. This means this one. This implies this one. 4 divides A minus B. So if I take A as 5 and B as 1, what is A minus B? This is 4, correct?
Excuse
And
me,
4
sir.
divides that, right?
Excuse me, sir. So,
Yeah.
could you explain the relation 4 by A minus B?
4
How?
divides, not 4 by.
Sir.
4 divides
Yes.
A minus B. So
How
basically,
does that signify or explain?
That means A minus B is a multiple of 4.
divides is plain division.
So how could you explain that A congruent B mod 4 is equivalent to 4 divides A minus
That is
B?
the definition of the congruence. That's how congruence is defined.
Okay.
If 4 divides A minus B, then we can write A is congruent to B mod 4.
Okay.
Yeah?
Thank you, sir. Yes.
This short
So
vertical
if,
line is sign for divide. I just said this short vertical line is the sign for divide.
Right. So suppose 4 divides 7 minus 3, right? Is this a correct statement? 4 divides 7 minus 3?
Yes, sir.
Yes, sir.
Yes,
Yes,
sir.
sir.
So from here I can write 7 is congruent to 3 mod 4. Is it clear?
Yes, sir.
Yes, sir.
Yes, sir.
Suppose let me take a little bit of more. So 16, not 16. Say 19 minus
Just a second.
3. So 4 divides 19 minus 3. Is it
Yes,
correct?
sir.
Yes, sir.
Yes,
So I
Yes,
can
sir.
write it 19 congruent to 3 mod 4.
I have
clear?
a doubt here. No,
Yeah.
I have a doubt here. Why do you place that bracket? 3 open bracket mod 4 and then close bracket. Is that the format?
It is the notation. I mean, there is no reason for that. That's how it is defined.
Because
this is the
usually for
notation
mod
we
we
are.
don't use, isn't it? See, generally when we say
You
mod,
can use or you cannot use, but I mean, it is also a standard notation by putting bracket outside mod.
so usually what happens is 3 mod 4 indicates it's for the remainder basically, right?
3 is the remainder basically.
Oh, 3 mod 4.
When you divide 19 by 4, 3 is the remainder, right?
Okay, no, but generally we use that mod notation. So there, what happens? Let's say 5 mod 2. That means 5 divided by 2 is remained. I mean, we will have to find out the remainder, isn't it?
That is what here we are doing. You divide this number by this number. This is the remainder.
Oh,
okay.
And for that, this is the notation.
Yeah.
Okay. This is new to me. All right. Thank you.
Yeah.
Sir, what is
bracket
congruent?
I mean, if you don't put bracket, then also it is correct. I mean, there is nothing wrong with it.
It is expected that the result should be a natural number, not a fraction here.
Yeah, because we are talking only about fractions. Only about natural numbers. So
Sir,
I have
please
started
tell
with
me.
natural numbers.
Sir, please tell me about congruence. What is congruence?
That is what I am telling for the past 5 minutes, no? Have you got that? Anything from this page have you understood?
No, I understood all of this, but except that congruence sign. What is that?
So can you explain me what have you understood till now? Then I can clearly tell you. What have you understood till now for this?
Okay, when we write like 3 is congruence of 1 bracket mod 4, then it means when we divide 5 by 3, then 1 is the remainder.
5 by 4.
5 by 4, right? Then 1 is the remainder.
That is congruence. That is the congruence relation. This is called congruence. This notation is called congruence.
Congruence. It is similar when we, I remember when I study in class 10th, there is a congruence triangle.
No, that is different.
They
That
are
is
congruent.
different. That is different.
Congruent.
Here we are not talking about triangles. Okay, that is a different thing.
That is
so basically,
different.
what
Okay.
I am saying, suppose I am giving you say again 19. Okay, 19 I am taking. So if I am talking about mod 4, modulo 4, this is called modulo 4. Okay, why that is that we call modulo 4, I will call later. Then what will be the remainder? So if you divide 4 by 19 by 4, then you will get 3, right? So here we can put 3. Is it clear?
Yes, sir.
Yes, sir.
Yes, sir.
Sir, is there a
What's
generic
the
formula
use of
to find the result? Like in whichever the way to write this notation, do we have a generic formula?
Formula of what? I am doing just division,
Ah,
right?
yes, yes. Here, just wondering, like every time we have to do the division, is there any generic formula, or we have to do the division all the time?
You have to do the division, no? I mean, the division is what we are doing here, nothing else. I don't know what formula are you asking for. So this is just the remainder we are talking about, right?
Sir, I have a question.
Yeah.
Sir, with which topic this congruence, I mean this all relate with
So
weak
what is
one
the use
background?
of this? Why we doing this?
Because we are talking about this is one equivalence relation and one important
It's a
equivalence
equivalent
relation.
relation.
And I think in the lecture it is also mentioned, right? This is one equivalence relation.
The equivalence relation is mentioned, but the congruence is not mentioned. That's why.
Congruence is one equivalence relation, one example of equivalence relation.
Yeah.
Just a doubt.
Okay.
Is it congruence or congruent? I mean, can you just spell that?
Congruence.
Congruence. Thank you.
Congruence.
That doesn't matter. I mean, do you understand what we are doing here actually?
Yes, sir. Sir, go on, sir. No, sir, not at all.
You are not understanding this one, congruence relation at all.
No,
No,
even I
it
don't,
was a
sir.
new subject. I mean, congruence,
This is
for
not
me, it was quite new.
mentioned. This is not mentioned
I
in
didn't
week
get it,
one.
sir.
No, this is mentioned in the lecture. There is a topic in the lecture where sir has taught
Yeah,
about
this
this, and
topic mentioned, but the congruence thing, this is not mentioned.
congruence is also
Guys,
mentioned.
this
That
is
is what
just
I
a
am talking about.
question. You
Congruence
guys
is not
don't.
mentioned, sir.
This is not a part of the course. This is a question. Try to take it as a question.
See,
This is a property of equivalence
forget about this.
relation.
Suppose I am giving you this relation.
Just an
In
example.
exam, I am giving you this relation. A4 divides A minus B. Okay.
Actually, I hear this congruence word for the very first time.
Forget about
That's why
congruence.
I
Forget
thought,
about congruence. Forget about
okay, okay.
congruence. Okay. Take set of natural number. Take this relation. Okay. Can you check whether this relation is reflexive, symmetric, transitive, or not?
Yes, sir.
First of all, is it reflexive?
Yes, sir.
No, I think.
No.
Yeah.
It is
What about A
reflexive,
comma
sir.
A? Take any
Yeah,
A comma
sir,
A.
it's reflexive.
It's
4
reflexive.
divides 0, right?
It's a reflexive, sir.
So it's a reflexive. Is it clear to everyone?
Yes, sir.
Yes, sir.
Yes,
Okay,
sir.
great. Great. This is clear to everyone, right? This is reflexive. Is
Yes,
it
sir.
symmetric?
Yes, sir.
Is it symmetric?
Yes,
No.
Yes.
sir.
Yeah.
Yes,
It
sir.
is symmetric.
Symmetric,
sir.
sir.
Okay. Those who are saying it is yes, can you tell me why?
No, sir, it is not.
No,
Yes,
it
sir.
is not.
It is reflexive.
No, sir.
So because if A minus B divides, then B minus A also divides.
It's not A minus B. It's it's like congruency, which is just sir explained us.
I am not talking about congruence. Forget that I told congruence at some point. Forget about that. I am giving you
No,
this
this is
relation.
A minus B.
So
This
what
is
about
not
B minus
symmetric.
A?
Not symmetric.
It is
Not
A
symmetric.
comma B is a symmetric relation, sir. Because
It
of
is symmetric, right?
yes, sir.
Because if 4 divides A minus B, then 4 also divides B minus A,
A
because B
minus B.
minus A is nothing but minus of A minus B.
Yes, sir.
Yes, sir.
Correct?
Sir.
If
Yes,
4
sir.
divides 8, then 4
Mhm.
divides minus 8 also, right?
Yes, sir.
Yes, sir.
Sir,
Is it
don't
clear to everyone?
consider the
But sir, then it won't belong to set to natural numbers.
I am not claiming that A minus B is inside natural number.
Okay, sir.
I am not saying this A minus B is inside natural number. I am saying only A and B are inside natural number. That is what I only require, right?
Sir, is 4 divides 0 defined or not?
4
No,
divides
it is not
obviously 4
defined.
divides 0.
Sir,
No,
But
0
it
divides
is not.
something is not
But it
defined.
is not defined. No.
0
4
divides
divides
something is
0
not defined. 4 divides 0 obviously it
is
is
0.
defined.
Is 0.
4
Any
divides 0
number
is 0.
divides 0, right?
0 by 4 it divides 0, sir.
I mean,
The vertical line,
Okay.
vertical
can't
lines
be 0.
any
divides.
number will divide 0,
Divide.
right?
Yes. We are confusing in this line. Okay.
Okay.
Denominator
Okay, you are
can't be
confused with this line. I remove this line. I will write divides. Okay. So 4 divides 0. Is it clear?
Yes, sir.
Is also
Yes, sir.
Can I write
transitive.
that?
Yes, sir.
Now, if 4 divides A minus B, can I say that 4 divides B minus A?
Yes, sir.
Yes, sir.
Yes, sir.
Is it clear to everyone?
Yes, sir.
Yes, yes.
Yes, sir.
Yes, sir.
Okay, great. What about transitive?
Yes, transitive.
Sir,
It
it's
is also
transitive, sir.
Why?
Yes, sir.
Because it
Yes.
is
Why?
reflexive.
4
Just
divides
take
B
element
minus
4, 8 and 12. 4, 8 and 12. 4, 8 is also divided by 4. 8 and 12 also divided by 4. And 4 and 12 also divided by 2. AB and
You
BC
are
and
giving an
AC.
example, but
Yeah.
how we can prove it in general?
Okay. A
B
comma B
divide
is
minus
satisfy
A.
the all condition itself, sir.
And
See,
4
A comma
divides.
B
C
belongs to
and
R
A
implies
comma
this,
C
right?
itself. Right.
Yes,
And
sir.
B comma
Divide A
C
minus
belongs
B.
to R means this. Correct.
A
Okay.
Sir,
Can you all mute just for 5 minutes? I am mute everyone. I will just explain, then I will ask, okay? Till then, you just listen. Okay? So I am saying A comma B belongs to R means 4 divides A minus B. That is the definition of the relation. Similarly, B comma C belongs to R means 4 divides B minus C. Right? Now, my question is A comma C belongs to R? That was the question. If that happens, then it is transitive. Correct? If 4 divides A minus B and 4 divides B minus C, so if I add these two, then 4 must divide that. So suppose 4 divides 8 and 4 divides 12, then 4 must divide the sum of them because it is divisible by 4, it is also divisible by 4. So their sum will also divisible by 4, right? So what I can do is, so from here I can write 4 divides the sum of these two. So eventually B will cancel out. So this is A minus C. So 4 divides A minus C, which implies that A comma C is inside R. This is yes. So this is a transitive relation. Is it clear to everyone? Now you can tell me.
Yes.
yes, sir.
Sir,
Yes, sir.
I just have one doubt. Like, we have to assume B comma C is an element of R. Is it?
I mean, that's how we check transitive relation, right?
Okay.
AB and BC, if those satisfy
Mm-hmm.
the relation, then what about A comma C? That is the question, right?
Yes. Okay.
Right, sir.
Okay. So this is a reflexive, symmetric, and transitive relation. Is this clear to everyone?
Yes,
Yes,
sir.
sir.
Yes, sir.
Yes.
Yes.
Yes, sir.
So
Yes,
this is
sir.
an equivalence relation, right?
Right,
Yes,
sir.
sir.
Yes.
Sir, can you
Okay,
share code?
fine. What?
Say code of, because I joined late.
I will share again. When I will share that screen, I will share it again. Okay. So this is clear, right? This is an equivalence relation. Is it clear to everyone?
Yes, sir.
So this is basically congruence relation. The name of this relation is congruence relation. Okay. I was telling nothing new earlier. Just I was giving the notation. But this is the relation I was talking about. Okay.
Okay.
So even if you don't understand congruence relation, Okay, but you remember that this is basically what is congruent. 4 divides a minus b.
Okay, that
Okay,
means
this is an equivalence relation.
right, sir.
Is it clear to everyone?
Yes, sir.
Yes.
Yes.
Yeah. Now tell me, what are the equivalence classes for this relation? From where we have started the discussion. So this is the relation. What are the equivalence classes for this? That means you take any, suppose you have set of all natural number. You take any natural number, say 1. Okay, I am putting 1 in a bucket. What else will be inside with 1? Can someone tell me?
5.
So 5.
5. Then
7.
5, 9. Every natural number will be there.
Every natural number.
13.
Every natural
17.
number that can't divide 4.
1.
17,
Sorry,
21.
sir.
15.
Every natural
So
number
this was
after
the
subtracting
relation
from
I
1 if
was
it is
talking
divided by
about.
Every
4.
natural number which will have the difference as 4.
With 1,
Remainder
right?
1.
Exactly. And that is the thing. Basically, here, all the natural number which will come
17,
here with
sir.
1, they have, yeah, right. So they have remainder 1.
Yes, sir.
Can you see that?
Yes, sir.
Why not 7?
Is it clear to
7
everyone?
divisible by
7
4,
minus
the
1 is
remainder is
6.
not 1.
So 7 will not be there, right?
Yes, sir.
If you take 2, what are there?
6.
Sir, 6 is
10.
there.
6, 10, 14,
14.
and so on.
14.
18.
20.
So can you tell me? Not 20.
22 will be 22.
Yes, sir.
22. 22 will be there.
So these are all the number which are remainder 2 when we divide by 4. Right?
Sir, excuse me.
Yeah.
Sir, when we take 7 in the first one and 7 minus 5
is 2.
Is 2.
Does 4 divide
That
2?
no.
There is no 7 in first class.
Minus 3.
No, if we take.
If we take, so 7 minus 5 is 2. 4 does not divide 2, right? So it cannot be in the same class. Is it clear?
Okay.
Yes, sir.
Clear,
If
no?
we take 7, we can take 3 now.
I will come to that.
Okay.
That's why I am.
Okay. Now when I take 3, what else will be
Then
there?
take 7. 7.
7, sir.
11.
Then
11, 15,
11, 15,
19.
19, and so on.
So if you check the numbers, these are all those numbers which are remainder 3 when we divide by 4. Correct?
Yes, sir.
Yes.
Okay.
Yes, sir.
If I take start with 0, so 0 is also a natural number.
4, 8.
What else?
4.
4.
8, 12.
4,
Or
8.
multiples of 4.
All
Multiples of
multiple of
4.
4. Basically, if we divide by 4, the remainder is 0. Correct?
Yes, sir. Yes, sir.
So this is remainder
1.
1. This is remainder
2.
2. This is remainder 3.
3.
And this is remainder 0.
0.
Got it? So this is a partition of natural number by this equivalence relation.
It means
And
these
are
are the
called
these are the only remainder possible when we divide 4 with any other number.
correct. No other number are possible, right?
These are the
Okay.
only partitions possible.
And these are all equivalent classes. So there are 4 equivalent classes. Correct?
Yes, sir.
4 are the equivalent
Yes,
classes.
sir. The all differences are 4. Okay.
Sir, I have a doubt, sir.
Yeah.
Sir, these are 4 classes or these are only 4 classes?
These
Only
are
4
only 4
classes.
classes.
Only 4
So
classes.
why can't we take 7 and then 3 and like
You
that?
can take any
If you
number.
take 7, then
but the
obviously 3
difference
is in the
4.
same class, no?
Oh, so remainder will be same. Okay, I understood.
That's what I am saying. There are only 4 possibilities, right? 0, 1, 2,
Okay,
3.
sir.
If you take this remainder, all natural number you are covered up. There are no other natural number remaining.
So, sir, in the relation, if we would have 5, then it would have 0, 1, 2, 3, 4.
Exactly.
Okay,
Exactly.
sir.
There will be 5 partition.
Now it's clear, sir.
It is clear to everyone? This is
Yes,
an
sir.
equivalence
Yes, sir.
relation.
Yes, sir.
Yes, sir. Yes, sir. Yes, sir.
This is an equivalence relation. And from this equivalence relation, we are getting these many equivalent classes. And that basically gives a partition of the set on which we are defining the equivalence relation.
Yes, sir.
Got it?
Yeah.
Yes.
Clear, no?
Yes, sir. 100%.
No doubt in that?
No, sir. No doubt, sir.
Okay, great. So similarly, when the discussion from where we have started this team thing, equalization of the players. So same thing was happening there. You take set of all international cricket players, each partition will be different teams. Right? Understood?
Yes, sir.
Yes, yes,
Yes, sir.
Yes, sir.
Great.
Excuse me,
sir.
sir.
Yeah.
Sir, I'm having doubt from activity questions. So, sir, may I ask?
Is this one clear to you? What I have
Yes,
just now
sir.
told?
This is clear to me. Yes, sir.
Okay. I will take activity question later in this session. Is that okay?
Yes, sir. So just one point I need to clarify that, sir, one statement is given as like X set, like X is a set because it is collection of different well-defined items. So, sir, can set have different collection of different items or not?
Why not?
It is actually
Yeah,
naive
collection
set
of.
theory.
I mean, just take a set like this: cow, say fish, say one, say
Actually,
ball.
the lecture
This
doesn't
is a set,
explain that.
right? 1 minute. When I am explaining, can you please
Yes.
keep you muted? Yeah. Is it clear? I mean, this is a set, right?
Yes, sir.
So they are all the items are different and they are well defined. When I tell cow, you understand what cow is, right? I can put that as an item in my set. We can do that.
Yes, sir. Thank you, sir. This was my doubt.
Sir, if we take real number instead of natural number in this question, then
Then it will be difficult. Then it will. I mean, I don't want to go there because that question requires some abstract algebra knowledge. So you really don't know how division work in real number. Do you know that? We
is
only know how
difficult.
division work in natural number. We don't know how division work in even fractions, right?
Yes, sir.
Yeah. So basically, this type division is working on set of natural numbers. Division, when we talk about division, we talk division on set of natural numbers, right? There is a notion of division in real number, even complex number. All these are there, but for now we are focused on natural number. Okay.
Yes, sir.
Yes, sir.
Okay, great. So this, at least this much is clear, whatever we have now discussed.
Yes, sir.
Yes, sir.
Yes, sir.
Very
Yes,
nice.
sir. Yes, sir.
Okay,
Yes, sir.
great. Let me go back to the next question. So this was the question from which we have started our discussion. Yeah. Now this question. Can you see this question?
So please share the link again.
Yeah, I will share this.
He scores more.
So a relation is defined. A scores more. So A and B are student basically here. So here we are talking about set of students for some course maybe. So A score more or equal marks than B. Okay, the score which A gets is more or equal to B, what B gets basically. So which of the following is or are true? So is this reflexive, symmetric, transitive, equivalence, antisymmetric? So I want you to write down this question and then solve it. Okay. So I will give you 2 minutes time for this.
Options, sir.
Done, sir.
Options.
Okay.
Done, sir. Done.
Done, sir.
Okay, so let me go to the next slide. You can put your answers here.
Hmm. Sir, can you show the teacher slide?
I asked you to write down that. Why have not you written down?
Sir, I write, but I not write with option.
Options are reflexive,
Symmetric
This one.
transitive equivalence.
anti-symmetric.
Yeah. Yeah, tell me, is it reflexive?
Yes.
Yes, sir.
Yes, sir.
Yes,
Sir,
sir.
it
By
is.
default,
Yes,
right?
sir.
It is.
Yes, sir.
So,
Yes,
yes,
reflex.
Yeah. Anyone has any doubt in reflexive?
No.
No, sir.
Yes, sir. I
No,
have a
sir.
doubt. How come it's
Yeah.
reflexive?
So A scores equal to A, right? If somebody's scores is compared to himself or herself, that is same, right? So more or equal is here important, right? Equal. So that's why A and A are related. Any student is created with himself or herself. Again, like the earlier one, right? Is it clear?
Yes.
Yes, sir.
Okay. What about symmetric? Is it symmetric?
It is not symmetric.
Not
It is
symmetric.
not symmetric. No, sir.
Not symmetric.
Not
Why it
symmetric,
is
sir.
not symmetric?
Because
Because
A score more
more
than or
than
equal to
B,
B.
Then B
but
But
B
can
not.
B is not
B is not
more
scoring
than
more than A.
Yes.
Correct.
A, more than or
So
equal to A.
I think it is
Correct.
symmetric, sir.
It is symmetric.
Why?
So because if suppose that A and B, suppose A is more than or equal to B. So if A is more than or equal to B, then B can also be equal to A. So if A is equal to B, then
Suppose
Not more than now.
more than
so
or equal. That
there
is
is
not
a
happening.
or option, not and.
Sir,
So in
the
and you have
two
to,
different students can have a same score, right?
Two different students can have same score. That is fine. That is okay. But here what is saying? This is basically greater than equal to relation, right? Suppose x is greater than equal to y. Is y is greater than equal to x? Can we write that? No, right? We can
Yes,
write
sir.
that only when y equal to x.
Okay, sir.
Only in that case we can write, and that is basically antisymmetric relation.
Yes, sir.
Yes.
Understood?
Yes.
Yes, sir.
If A gets more or equal than B, and B also gets more or equal than A, then we can conclude A and B must get equal. Correct? And that is the property of antisymmetricity. Is it clear?
Yes, sir.
good, sir.
Yeah. Okay. So it is not symmetric. Is it transitive?
No.
No, sir.
Yeah, it is transitive.
I think, sir, it is
Yes, sir.
transitive,
It
sir.
is transitive.
No.
It's transitive.
No, sir. It is not.
transitive.
It is transitive.
So those who are saying it is not transitive, can you tell me why?
So
Suppose
because
A gets more or equal to B, and B gets more or equal to C. Can we say about the comparison between A and C?
Yes,
What
sir.
can I say?
Yes, sir, we can.
Yes, sir.
A gets more or equal than C.
Right? A gets, obviously A gets more or equal to C, right?
Yes, sir.
Sir,
Yes,
I
sir.
want to ask
Everyone?
that in the question only A and B is mentioned. Should we consider to C also from our side?
You just
I will
assume
suggest
C.
you go back to 1 minute. I will
We can
suggest you to
assume
go
it.
back to the lectures again. Okay, you are missing the basic point of this representation. So here A and B are just notation. These are collection of all such ABs.
A,
right?
B, and C are just representing three
Anything,
different
anything. They
elements
are
from the
just
set.
elements, right?
Right.
When I am saying that, suppose, let's say set of real numbers, I am saying x. Okay, so here x is not a particular number, right? I mean, say as set I am
It is all
taking
real numbers, right?
all real number, right? X belongs to R. So x is just a notation for that, correct? So when I am talking about this a comma b, and there are some properties, I am talking about all such pairs which has this property. That is not particular a or particular b, right? If I say x and y also belongs to R, then they also satisfy this property, right?
Got it, sir.
Okay. So transitivity is clear? Why
Yes,
it is
sir.
transitive?
Yes, sir.
Yes, sir.
Yes, sir.
Is it equivalence?
No, sir.
It won't
No,
be.
No,
sir.
sir.
No, sir.
No, sir.
Because it is
of
not
symmetric and
symmetric.
Because
transitive
not
is
Symmetric, right, correct. Antisymmetric, I have
Yes, sir.
already
Yes.
explained.
Yes,
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 it
sir.
is
Sir,
antisymmetric.
Yes,
yes,
sir.
sir, that is
So
anti-Semitic.
option 1, 3, and 5 is correct,
5.
Correct, sir.
right? Yeah.
Yeah.
And
So
sir, if
many
So
of
why
you
it is
have put option
anti-symmetric?
2. Huh?
Because it
So
is
why it is anti-symmetric?
If A gets more or equal to B. So you understand this thing? If these two happen together, then I can claim x equal to y,
Yes, sir.
right? Same thing is happening. If A get more than B, more than or equal to B, and also B get more than or equal to A, what can I conclude? If A is strictly more than
both
B,
have
then
scored
the
same mark.
second case cannot happen, right?
Yes, sir.
So they must be equal. Correct? Understood?
Yes, sir.
I don't get it, sir.
No, is
I'm
it because they are equal? We call it antisymmetric. Antisymmetric?
No,
No.
What does it mean? Is it equal? Then antisymmetric mean what?
No, you said
Antisymmetric is the relation, right?
Yeah. No, so if in a relation, if in a relation it happens that these two numbers will always be equal, then it will be called as antisymmetric. Is it something like that?
No. Nothing like that. Okay. Here, what I am saying, if x is greater than equal to y, okay.
Yeah.
Now, you know y is also greater than equal to x. From these two, what can we conclude? Can we conclude x equal to y or not?
They are equal.
Sir, I want to
equal,
ask
right?
how these both conditions are simultaneously equal.
They can
Possible.
be simultaneously hold only when x and y are equal. Otherwise, this cannot hold. That is the point.
Understood.
If x is only strictly greater than y, then this second condition cannot hold. Y cannot be greater than x. It will only possible if equality hold.
Sir, please mute all. I don't get you.
I mean, I cannot do this mute every time I require, right? That should be their responsibility also. Okay, so what I am saying, if x is greater than equal to y, suppose you have this one, right? When can also I can write the opposite one? When I can write y also greater than equal to x. If x is strictly greater than y, we cannot write this opposite one, right?
Yeah.
See, I don't think she has understood again. So 3 greater than equal to 2. Can I write this? Is this true or not?
Yes, true.
Can I write 2 greater than equal to 3?
Yeah. No, sir. No, sir.
No.
No, right? Can I write 2 greater than equal to 2?
Yes, sir.
Yes.
If I now interchange this position, will I get the same inequality?
Yes.
Yes,
And
sir.
when can we do that? We can do that only when these two numbers are equal.
Same, yes.
That is what here we are doing. Is it clear?
Yes, sir, got it.
Sir, one
Yes,
doubt.
sir, I got that.
Sir,
I got
I
that
have a doubt,
explanation,
sir.
but I didn't get that anti-symmetric definition. That is
Yeah,
what.
that's
Okay, that I will tell.
Sir,
Any other?
Antisymmetric definition just says if A B belongs to R
I will tell the
and
definition.
BA belongs
I will
Guys,
take.
please.
I will take.
I am
like that.
asking.
Okay, okay.
Yeah. Any other doubts here?
sir, I have
Other
a
than the
doubt,
definition?
sir.
Yeah.
Sir, actually, in week 1 graded assignment,
In
question
this
5,
problem,
I didn't understand, sir. Sir,
in
could you
this problem,
explain
have you
that?
any doubt? I am asking whether you have doubt in this problem or you are talking about some other thing, right?
Graded
In
assignment will
this
not
one,
be.
can we say
Guys,
all?
please check
of
the
the-
previous video for the asymmetric, antisymmetric.
Yeah, sir. The question is, can we say if anything which is not symmetric is all anti-symmetric, or there is some space where
No, there is
anything?
no such thumb rule. Okay, no such thumb rule. Okay, it can neither symmetric nor antisymmetric. That can also be possible. Okay. So I am saying that so forget what is the definition of antisymmetric. Antisymmetric means if A and B are related. Okay, A and B are in R, right? And A and B are not equal. They are not equal. Then BA cannot be in R. Okay, it is like opposite of symmetricity. What symmetricity says, when A and B are in R, then BA must be inside R. But antisymmetricity is saying if A and B are inside R and they are not equal, then B comma A cannot be inside R. Okay.
Okay, sir. Got it, sir.
If X is greater than equal to Y, okay, and X and Y are not equal, then Y cannot be greater than equal to X. Correct? It cannot be. This is antisymmetricity. They can. This is only possible when X equal to Y. Otherwise, it is not possible. Is it clear?
Yeah. Can you just show one example where it is not symmetric and not anti-symmetric as well?
No, so this equality, if the number, the thing we are considering, they are not equal, then obviously when it is not symmetric, there must be anti-symmetric. But the problem is arising with the equality, whether the concept of equality comes in that place. Okay?
Okay.
Okay, great.
So if
Is
with
it
the
clear to
given
everyone?
equation, but so with the given equation, what if two students have same marks? Because the equation is
Then
greater than or
in
equal
the
to.
same. Then what
But
is
then
Cannot
both
be
the
antisymmetric,
students
sir, no.
will be
But sir,
different.
this cannot be antisymmetric then, no?
Huh?
If two students have same marks, we cannot
they
conclude that
are-
it's antisymmetric.
But there, I mean, relation is altogether antisymmetric. You are talking about some particular element. Suppose two students, say student 1 and student 2, they got same marks. So they are inside R. What is the issue with that? There is nothing.
Sir, but the
no issue with
two students are different, their marks are same, but we will write A comma B. For antisymmetric, the both elements would be equal in the pair.
Here,
Here-
we are not talking about relation on the
Sir.
numbers. We are talking about relation with the students.
Sir, here the element is the set is of students or set is a student score.
I think it's probably
It is a
about
set
the
of
score.
student, not scores. Student.
So then,
Here the relation is also with the student. Understand that.
no, sir. If my marks is like say 20 and some another student mark is also 20, so you are saying that my and his we are same. The set should be of the student score then, sir, not student.
No, I am not taking out the marks. I am talking about the students. So forget it. You understand what antisymmetricity is?
Sir,
Yes,
actually,
sir, we understood
I
what
understand the
antisymmetry-
relation, but I don't understand when you say it that it is a set of a students. If it's a set of a student, then two student cannot be same, na? Because all the student can get the same marks, or two students can get the same marks.
I
It should be the set.
understand where your doubt is. I understood that. Yeah. So basically, if you are saying,
I'll
I
agree to
understood
this
that.
only if this is a set of a student score and not student.
And even if we mention that all students are getting distinct marks, then also you will agree, right?
Yeah,
Yes,
I'll
sir.
agree with
Only
that also.
when it will
Yes.
be
Right,
anti-symmetric.
right,
Yes.
right. I understood that. Yeah, take that condition. No student are getting same marks.
That's fine.
Okay,
Okay.
take that
It's
condition. Then it is
strictly greater
anti-symmetric.
than,
Is it
sir.
clear?
So
Yeah,
it's strictly greater than.
strictly greater than. Yeah.
Thank you,
I
sir.
mean, then also there is an issue with this anti-symmetry problem. Then
It will be not be reflexive then.
reflexive, right?
Yeah.
It will not be reflexive in that case.
Yeah.
Okay. So basically, I wanted to focus on the greater than equal to relation. So that is the anti-symmetric relation.
Understood, sir.
Right? Yeah.
Sir, I understood all relations, but problem is only with the question.
I got your point. I got your point. Right.
Right.
Okay.
That's why I asked about same score.
Okay. Got it. Okay, fine. So this is, I think, hope it is clear. Yeah. This one, I think should be a little bit easy, right? Can you see this?
Yes. Yes, sir.
Yeah. Okay. Okay, so the function is defined as fx equal to x square, and the problem is whether it is injective, surjective, bijective, or none of those. Okay, so can I go to the next slide?
Yes, sir.
Yes.
Where you can give
Yes,
your
sir.
Yes, sir. Yes, sir. Yes.
Okay, sorry, not this one. This one, right? 1 minute. So have you written down this problem?
Yes.
Yeah, give me a minute. Can you see the screen now?
Yes, sir.
Yes, sir.
Yes, sir.
Okay, fine. This one. Okay. Okay, so I hope you have understood the question, right? If x equal to x square, then can someone tell me when a function is called injective?
Yes, sir.
One-to-one function, sir. When domain function is have uniquely connected to
For a unique input, it must be unique
unique
output.
unique output.
For every
So
input, there is a
basically,
unique output.
Sir,
Suppose
every
this
element
is
has exit only.
okay, understood. So if we have domain and codomain, and here is your function A, two element cannot go to the same element, right?
Yes, sir.
If this happens, then this is not injective. Clear?
Yes, sir.
This cannot happen, correct?
It's subjective.
Now, here what is happening? Fx equal to x square.
As a square function,
What
cannot be
Plus and minus
injective.
are same the value.
Injective.
What is the value of f of minus 1?
1. F plus 1 is also 1.
1.
And what is the value of f of 1?
1.
1.
So there are two elements which are going to the same number, right?
Yes, sir.
Same element. So it is not injective.
Not injective.
Is it clear to everyone?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Yes,
Some
sir.
of you have put injective as the correct option, so it is not correct. Okay, fine. Is it clear to everyone, or anyone has any doubt?
Yes, sir.
Clear,
Clear.
sir.
No, sir.
Clear, clear.
Clear, sir.
Clear, sir.
Now, when a function is called onto,
When its
this is
codomain
very
equals range.
Yeah.
what does it
Codomain
mean?
and
What does it
Sir,
mean?
or codomain have the pre-image in domain.
All
Exactly.
codomain values are used.
Exactly.
Yeah.
So
Yes.
basically, if we take all this domain, suppose this is my thing. So here, the set of output, this is called range, right? And if range and codomain are the same set, they are equal, then only we can say f is onto, correct? So
Yes, sir.
you take any element from the codomain that must have a pre-image, that must have an input, right?
Yes, sir.
This is your domain, this is your codomain. So how you check? You take any element from here, any element. It must come from an input. There must exist something here, something in the domain for which the image is that element, right? If we can prove that, then the function is onto. If it is not the case, then it is not onto. Clear?
yes, sir.
Yeah.
Okay.
You provide one. Can you provide example? One example. Like
This is the example which we will do now. Fx equal to x square. Can you tell me what is the range of this function?
Always positive.
Always
0
positive.
to positive infinity.
Exactly. So
0 to
all
0 to
those
infinity.
x which are greater than equal to 0 and real number,
Yes.
right? All those positive number and 0 also included, right? Non-negative real number. And when I have mentioned this function, this is from R to R, right? What was the codomain? This is the codomain,
Real
right?
number. Yeah.
Real number. So is codomain and range are equal here?
No, sir.
No.
No, sir.
No, sir.
So is it onto?
no,
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 sir.
sir.
Right? No.
And sir,
So
if
what
R
I
to R is not mentioned,
it will always be mentioned. Otherwise, you cannot tell whether function is onto or not.
or by default, we can take this in some.
Unless it is mentioned, unless the codomain is given, you cannot conclude it is onto or not.
Actually, in some of the questions, sir, it is not mentioned.
No, if it is not mentioned, then it is written that it is real valued function.
Yeah, yeah, okay. So real value.
Real valued function means codomain is real. Set of real number.
Okay, sir.
So basically, it should be mentioned in the question somewhere.
Yeah, I have.
Either it is
I
mentioned
have
as real valued function or it is precisely mentioned. Okay.
Okay, sir. Okay.
Okay. So suppose I take minus 4. Does minus 4 has a pre-image?
No. No, sir.
No, sir.
So minus 4 is in the codomain, right? It is here in R.
Yes.
Minus 4 does not have a pre-image, right?
Yes, sir.
Yes, sir.
So it is not onto. Clear?
Yeah.
Yes, sir.
Yes, sir.
Not onto. Or not subjective. Whatever you say.
But sir, is there any way to prove it? I mean, systematically. This is based.
So,
what
so
if
basically
like
when you are basically when you are saying something is not one to one or not onto, you have to give an example that this does not have a pre-image or these two element is going to the same element. If you want to prove something, if something if it is 1 to 1 or if it is on 2, then you have to choose one element from the codomain and give the p-image. So let me take this example, fx equal to 2x plus 3. Okay, an easy example let's take. Is it 1 to 1?
Yeah.
Yes, sir.
Yes, sir.
How we can show it?
F of 1.
It's a linear equation.
For
Sir, by
every
taking two values x1 and x2 and fx1 is equal to fx2.
Right. Suppose there are two input, say A and B. I will take A and B, for which the output is same. Suppose this is happening. So what does it mean? FA should be equal to FB.
Yes, sir.
Now, can this happen?
2a plus
also
3.
It cannot happen because FA is basically 2a plus 3, FB is basically 2b plus 3, then 3 3 cancel out, 2a equal to 2b, then A equal to B. So if I mean, it can only happen when A and B are equal. It cannot happen when A and B are not equal. For two different output, it cannot give same input. So it is 1 to 1.
Yeah.
Take example of x square, sir. Then by this.
This will not happen, no?
If you take -3 and 3, the value will be same, no?
So, I mean, A square equal to B square does not mean A and B are equal.
So from here, A is equal to B and A is equal to minus B, 2 will come.
So two options can come, right? So just taking example is enough. It is not 1 to 1.
If you remove square, it will be plus or minus A equal to plus or minus B.
Right. Now, how can you show that this is on 2? First of all, is this on 2?
Yes, sir.
Because range
Why?
and codomain are equal.
Why? What is the range of this function?
Real number.
Real number.
Real number.
Why?
Sir, because any real value can be broken into 2x plus 3.
Exactly. So what you are doing, you are taking any element, say M from the codomain. Codomain is R. This is my codomain, right? Does M have a p-image? That means, does there exist? So let me write, does there exist some input x for which fx equal to M? So this is the question. If such x exists, then we can say this is on 2. So basically we have to find x for which fx equal to M, correct?
Yes.
Can we find such x? So fx basically 2x plus 3. So what x can be? M minus 3 by 2. And this is also a real number, correct?
Yes, sir.
Yes, sir.
So if I take f of M minus 3 by 2, then the output I am getting is M.
M.
So M has a pre-image, indeed.
Okay.
So it is on 2. Is it clear?
Yes, sir.
Sir, one doubt.
Yeah.
How will be the graph of this surjective function? Is it like same of that of injective?
I mean, why are you asking this question? I am not getting. Graph of any injective function, we cannot tell anything like that, right? Or graph of any surjective
Sir, I
function,
think
we
he is
cannot tell
asking
anything
about
like
horizontal line test.
Yeah, yes, sir. Actually, I didn't wanted to mention that.
But so I also didn't wanted to mention that because it will confuse many students.
Actually, sir, I was in last qualifier batch, so I have read those 4 weeks.
Okay.
That's why this doubt came in.
No, basically horizontal line test can be used only for 1 to 1. Okay. For on 2, we cannot do like that because if the range is whole R, basically, suppose codomain is whole R, then the plot will distribute all over R. That is only, you can say, only when the function is on 2, nothing else.
Sometimes it
Right?
intersects once and sometimes more than one.
That can happen.
Okay.
And if you take the function graph of x square, this look like this, right? It will go to high 0 like this. So it is only to R. There are no points coming from here, right? So it is not on 2. That you can say.
So is it necessary for a surjective function to pass the horizontal line test?
No. Why? Only horizontal line test is only for
Injective.
Injective.
Yeah. If you say this 2x plus 3, what we are doing, that case, this is injective also, right?
So
2x plus 3.
if the graph will be spread over all over the entire range of real numbers,
This will the graph of 2x plus 3. It is on 2 anyway. But from the graph, I mean, this is all over R, so clearly this is subjective.
Yes,
but
sir.
horizontal line test does not confirm it.
But it is passing the horizontal line test. So can you draw
because it is 1-to-1 also.
Uh,
because it is 1-to-1 also, no?
So, sir, can you give some example which is not passing the horizontal line test, and it is surjective too?
Okay. So basically that too is my next example. So let's do the next example. Then I will come back. Will that be okay? Because next example is exactly like that. Okay. So if you see this next example, you can understand why I was saying that. So here, observe that codomain is changed, right? Codomain is set of positive real number, including 0. Okay, R plus mean R positive, including 0. So, I mean, this will be easier. So I will go to the next slide directly. Yeah. Can you put your options here?
You should have, sir, asked this question before.
Yeah. So if I go back to the question, so first of all, is it injective? Again, the same question.
No.
No.
No, sir,
right?
not easy.
Because again, suppose you take -1 and 1, both of them are going to 1, right? So who are giving injective as the correct answer have not even understood it. Because many of you have given injective as the correct option. You can ask me whether it is clear or not. Anyone has any doubt that this function is not an injective function?
No, sir.
Anyone?
I have doubt, sir.
Yeah, for which one? Injective one, is it?
Yes, sir.
Okay. So injective means what? Injective means no two element from the domain can go to the same element.
Same
right?
element.
This
Yes,
was
sir.
the definition.
Yes, sir.
Two element cannot go to the same element. This cannot happen.
Every input has a unique output.
Right. So if fx equal to x squared, if I take f of -1, what is the output?
1.
1. What is the output of 1?
1.
So both -1 and 1 are going to the same element, right?
Yes, sir.
So it cannot be injective.
Yes, sir.
Understood now?
Yes, sir.
Okay, great. Now the second question was in this scenario, now the function is defined like this, r plus fx equal to x squared. Is it surjective?
Yes.
Yes, sir. Yes, sir.
Yes, sir.
Now the question is, what is the range of this function? You have already told me earlier. What is the range?
0 to plus infinity.
0 to
Exactly.
X is greater than
0 to infinity.
This, right? All the real numbers which are greater than 0. And this is exactly the codomain here. My codomain is r plus here, right?
Yes. Yes.
So here codomain and range are same, right? So if I change my codomain, the same function can be surjective. Earlier it was r to r. Codomain was r. Function was same. But the codomain was r. So it was not on 2 in that case. But here it is on 2.
Yes, sir.
Is it clear?
Yes, sir.
So who is asking about the horizontal line test now? Can you understand now? The same graph. So it only depends on the codomain.
Yes,
That
sir.
is what I was telling. Understood?
Yes, sir.
Okay, great.
And sir, if
Anyone has any doubt in this?
And sir, if domain is also R plus, then it is bijective, right? R plus to
So
R.
I have a doubt in this.
Yeah. Correct. Yeah.
Here, if for example we take 1, 2, 3 and we take a square root of this according to this function, there would
According
be
to this
some,
function, mean what is your function? Square root
yeah,
or
the
square?
square.
Okay.
In this case, a few elements, a few numbers would still be left out in R, because if we take x is equals to 1, it will be 1. If we take x is equals to 2, it will be 4. So in this case, 2 and 3 are left out. So how come
2 and
it's
3 for the
surjective?
from the codomain, is it?
Yeah, from the codomain.
Okay. So let's take 2 from R plus. Okay. You are saying that has no P image, is it?
Yeah.
What about f of root 2?
Yeah, 2.
Okay.
Root 2 is a real number, right?
Yeah.
I am not talking about natural number. This is set of real number,
Okay, understood.
right? So all are included. If I change this to a natural number, then what you are telling is correct.
Okay.
But I am not claiming the domain is natural number. Domain is real number.
Okay, sir. Understood now. Yeah. Thank you.
Yeah. Whatever thing you take here, A, you just take root of that. That is in your domain because root A is a real number. If A is positive.
Okay.
Right? That's why the range and codomain are important. If A is negative, then root A does not make any sense. If A is negative, then it is a complex number, which is not in our domain. Clear?
Understood. Thank you.
Okay, great. Any doubt in this question? So this question was basically to give you an idea that codomain is basically an important thing to verify whether it is surjective or not. Okay, same function can be made surjective by changing the codomain. Is it clear to everyone?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Great.
Yes, sir.
Yes, sir.
Great. So till now, no doubt?
No doubt.
No doubt.
Okay, this one. This is mod function. You understand mod function?
Yes, sir. Only positive values.
So if you
Yes, sir.
if whatever the value inside the mod, if it is positive, the output is positive. If it is negative, then the output is also positive. So it transforms negative to positive values. That is the idea.
So option, sir.
Huh?
Option.
Injective, surjective, bijective, none of this. So yeah, I will go to the next slide. But before that, we just look at this problem and write this function. Okay. I want you to find the range of the function also. Okay.
Next slide, sir. Next slide.
Going. You just let everybody do this. Yeah, now put your answers.
Done, sir.
Okay, again, many of you have put option 1 and 2 both correct, and option 4, many of you have given correct. Okay, so this is mod of x plus 4. First of all, is it injective?
No, sir.
No, sir.
No, sir.
Why?
No, sir.
Can
No,
you
sir.
give me two element for which
-4
the
and
image is same?
-8/2.
Its range is minus infinity to
So
infinity.
minus 9 and 1.
So first someone said -4. So for -4 it is 0.
0.
And
Yes, sir.
what was another one?
-8/2.
Sir, instead of
8
taking
by
a
2.
particular element, can we go through proof method?
You can go,
Minus.
but we don't require a proof for this because this is not one-to-one you are
So
claiming.
just
No?
practicing, that's okay.
You go there. No issue with that. I mean, that will be even better if you can do that.
Yeah.
-8/2 is not 0. Why you are saying that? -8/2.
So minus 8 and minus 4 are same.
So
Yes, sir.
-6 and -2.
So why someone was saying that? -4 and?
No, sir, -4 not. -6 and -2.
Okay. So -6. -6 is 2.
2. -2.
And -2 is also 2. Correct. Okay.
Yeah.
So basically, when I am talking on mod function, if you remember mod function, what it does, it takes all the positive numbers to the same number if x is positive or 0. It is -x if x is negative. This is the definition of mod x, right?
Yes, sir.
Correct? It is x if x is greater than 0, it is -x if x is less than 0. Now here instead of x, it is x plus 4, right? So as you have discussed that this, if I take -6, I am getting 2. If I am getting -2, I am getting again 2. So two elements are going to the same number, so it is not injective. Clear?
Yes, sir.
Yes, sir.
Okay.
Yes, sir.
Fine. Is it clear to everyone?
Yes,
Whoever have given
Yes.
it as injective
Yes,
option
sir.
for them.
Is it clear, sir?
Okay. Is it on to?
No, sir,
Is
it
it
will
on
produce
to?
only
No,
positive
sir.
No,
values.
sir.
No.
No.
It is R2R, so it is only producing greater than 0, right?
Yes, sir.
Yes, sir.
Can someone tell me what is the range of this function?
Yeah.
0 to
-4
infinity.
0
to
to
infinity.
Infinity, sir.
0 to
Not to
infinity.
infinity.
Positive.
Exactly.
Minus
It
4
is
to infinity.
Close bracket
-4
0 to
All positive
infinity.
real
All
numbers.
positive
R
real
class
numbers.
basically.
-4 to infinity is range.
Yes, sir.
Yes, sir. Right, sir. Agreed.
-4. -4,
Yes.
how -4 will come? Because always
Sir,
it
Will
will
open
tend
with
to
a
positive,
minus.
no?
Yeah.
Output is always positive.
How -4 will come? It will not come, right?
Sir, it will be 4 to infinity
Why?
because
Sir,
if
range is -4 to infinity because the mod which are inside greater than equal to 0. So x plus 4 is greater than equal to 0. There may be when the 4 go to the another side. So x is greater than equal to -4.
What about f of
How
-6?
can you tell me how suppose -3? What is the p-image of -3? Can you tell me that?
1.
First of all, can it
1.
come? It is mod function. Whatever in value will get an output, that must be greater than 0, right?
We are not
The
considering the value
value
of
of
x, we are
So
considering
what
the
you are
output.
saying is kind of going to
Yes, sir.
another direction. We are not concerned about that. This value, whatever this value, this should be greater than equal to 0. This cannot be negative, whatever value you give, right?
Yeah,
So
yeah.
maybe they are
Yeah.
considering the value of x instead
No,
of
I understood
entire
what they are
function.
doing.
Yeah.
Yeah. Now someone has told me that this is from 4 to infinity. That is also one argument. But I mean, cannot be 0 and output if you take
it can be,
-4.
sir.
Yes.
Yes, it can be.
So -4 plus 4. So it's
It
0.
can.
0 can be an output,
Yes, sir.
right? Yeah. Yeah. Can you show me how the graph of this function look like? First of all, do you know how graph of fx look like?
Sir, in the
Fx
other way,
equal to
we
mod
can
x.
say the least possible value output is
Like a
0.
V.
Sir, V shape.
Sir, just like
Like
x square.
Not
Sir,
x
V
square.
shape.
X
The
square is
tip
there.
of the V will be on point 4.
Yeah, yeah. It's tip on the 4.
This is fx, right? This is fx equal to mod x, correct?
Yes, sir.
Yeah, yeah.
Okay. Now, what about this function? What we have given?
So we will shift
Then
this
So
graph
y
4 units
intersection
to
would
left
be
arrow.
It will
Unit
shift
upper.
right side 4 units.
Hmm?
so y intersection would be plus 4, 0.4,
So here, and then
and then
here,
it will be v safe.
V shape from where? Here, right?
Yes,
So
yes.
minus 4 comma 0.
Yep.
shifting up.
Yes, sir. This is the
Correct?
Yes, sir.
No,
This is
sir.
the graph.
Yes, yes.
No. 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 Sorry.
no, sorry.
No, it is correct. No.
It's
No,
correct.
sir.
No, sir. No,
Sir,
sir.
it will be vertex will be on x-axis
So it's on,
at
it should be
minus
on
4.
x-axis.
It will be.
At minus
Yes,
four.
it's good
Yes,
to
yes.
yes, sir.
Yeah.
That's
Yes,
okay.
sir.
This is the graph, right?
This is
For
the
minus 4, it should be 0. And
Yes,
then
sir.
from here is V shape will look like.
Yes, yes.
Right? So if you consider the range is basically same for the both the function, right? This upward portion. This is the range. Correct? Domain is also the same. Only this point where the function touches with the x-axis, that is changing. Nothing else will change. Is it clear?
Yes, sir.
Yes, sir.
Okay, great. Clear to everyone, na? The function, how
Yes,
it will
sir.
change?
Yes, sir.
Yeah,
Yes, sir.
definitely, sir.
Sir,
So if I take a fx equal to mod x minus 4, then how it will change?
So 0
So it
touches
will
on
start
plus
from
4.
4 comma 0.
It will start
So
from
it will shift to the right. The graph will
like this, right?
Yes, sir.
Yes, sir.
Correct?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Okay. Last example I will ask, fx equal to mod x plus 4. How it will look like? Now
So it
4
will
is
shift
outside.
4
Upward.
units in upward.
It will shift
Upward.
4 units in y-axis.
Yes, sir.
Upward.
Like this, right?
Yes.
Whatever I have done earlier. Correct?
sir,
Correct.
What is the range of this function?
4 to infinity.
4 to,
4
4
to
to
infinity,
infinity.
sir.
Correct.
4 to positive.
Clear? 4 included, huh?
Yeah, 4 included.
Close.
Yes.
excuse me, sir.
Yeah.
Sir, what is the domain in this graph?
Domain is always
Domain is all
R
real
here.
All real number.
All real
Real
number.
number. Because any
R to
input
R.
you can give, right? Any input you can give. Whatever the real number you have in mind, you can take it as input. Right?
Oh, okay, sir. Okay. Thank you.
So the function is defined for all those real number. Every real number.
Thank you, sir.
Okay?
Okay.
Okay, great. So clear, right? This question is also clear.
Yes.
Yes, sir.
Yes, sir.
Yes, sir.
Okay, great. This was an easy question then. Domain of the function.
Sir, option B will be the correct answer, I think so.
Solve it, then we'll see.
Option D.
D, sir, option D.
I will give you the option to put, no? Why are you telling? Has everybody written down the function x plus 12 by 4x minus 8?
Yes,
Right?
sir.
Okay. And options are R set minus 1 by 4, R set minus 12, R set minus 2. Okay, these are the 4 options.
Yes, sir.
Now you can give the options. Okay.
Done, sir.
Okay, great.
Done, sir.
Okay, so basically when you have to calculate the domain, what does it mean? What are the possible set of input, right? That is the domain. I mean, for all those values of x for which this function is well defined. Now the function is given as x plus 12 by what was in the denominator?
4x minus 8.
4x minus
4x
8.
minus 8.
Right. Now, when this function is not defined,
When denominator is 0. When the
when
denominator is 0.
right? Only
Yes,
in
sir.
that case the function is not defined.
Yes.
So when it is 0, then the function is not defined. That means when x is 2, then only the function is not defined. Other than that, take any value for x, the function is well defined, right?
Yes, sir.
Yes, sir.
So domain of the function is all real number you can take,
Except
but not 2. Is it clear?
Yes.
Yes, sir.
Yes, sir. Yes, sir.
So mainly
Yes, sir.
two type of function generally occurs in this type of problem. One type is something is under root, right? And then something is like this fraction. Only these two type cases occur and some mix up of these two cases. So basically, when this is possible, I mean, when this function is defined, when
X greater
whatever
than
inside
equal
the square root should be greater than
or
0,
equal to.
greater than equal to 0, right? Suppose I am giving you fx equal to root x minus 2. What is the domain of this function?
2 to
2 to
infinity.
infinity.
So
Greater
this
than
whatever
equal
is
to
inside
0.
that should be greater than equal to 0.
To 0.
Yeah.
So all x for which greater than equal to 2. So the domain of the function is 2 to infinity.
Close interval 2 to infinity.
Clear?
Yes, sir.
Yeah.
And for this
Yes,
type
sir.
of fraction function, the denominator should
No,
not be
zero.
equal to 0. Clear?
Yes, sir.
Now you have to take care of only these two, and there are some mix-up function like this, which both, which contain both square root and the denominator. So then you have to do for the both and see which are the basically portion for which the function is defined. Okay, that is the idea. Is it clear to everyone?
Yes, sir.
Yes.
Yes, sir.
Okay.
Why is to include?
Huh?
Sir,
Let
I
root
don't
y.
understand why except 2.
Why?
Why except 2 in this question?
If you put 2 as an input, the denominator will be 0, right?
Yes, sir.
So can denominator be 0 for a fraction? Is that defined?
No, sir.
No. So only when this function is well defined to all other points, only except to the point for which this denominator is 0. Only for that point the function is not defined. Otherwise it is well defined. So when it is 0, it is defined 0 only when x equal to 2. So we remove the 2. So except that 2, if you take any real number, the function is defined. Is it clear?
Yes, sir. Now clear.
Great. So last question, I am saying earlier that this is little bit tricky, but we will end our discussion with this problem. So this is natural number to natural number. When n is odd, the function is 2n. When n is even, the function is n by 2.
Sir, do we have to consider 0 as a natural number?
Consider that. Consider that.
The 0 is neither odd nor even. We are
Consider
considering
0 as even.
Even, yeah.
Even. Yeah.
So then you can move to.
I will not, there is no other slide which I have created. So I will take answer from you directly. Okay.
C option.
Sir,
C.
Answer is C, sir.
answer slide.
C.
C, sir.
C.
C.
Option
Okay,
C.
let's see. It is on 2 but not 1 to 1. Let's see. So the function is given as f n to n fn
It's injective, not surjective.
n is even. 2n for what is given?
N is odd.
N is odd, right? And n by 2 when n is even. Okay. So first of all, is it injective? Are there any two natural number for which the image is same?
Yes.
Yeah, yeah.
So
Can you tell me which one?
F1.
1 and 4.
1 and 4.
1 and 2 basically.
1 and
First,
4.
yeah,
Four,
maybe
sir.
first if you take
1 and 4.
1 and 4, right.
Yes,
For
sir.
1 it is 2 and
Yeah.
for a 4 it is 2.
2.
Okay, so it is
Not
not
injective.
injective. This part is clear to everyone?
Yes.
Yes, sir.
Yes.
For 1 it is odd, so we are doing this function. For 4 it is even, so we are doing this definition. Okay. Now the question is why it is, I mean, it is subjective or not? And if it is subjective, why?
So it is subjective because for every natural number, there is a pre-image.
How? How we can prove that?
So because all odd numbers will generate all even numbers, and all even numbers will generate all the natural numbers.
What does it mean? You are telling it correctly, but little bit more precise.
Sir, it is about bijection.
The range equals to codomain.
It is not bijection clearly because it is not injective.
Not
right?
injective, right?
Sir, we can say that range equals to codomain.
Range is equal to
Why? That is I am asking. Why range is equal to codomain?
So we can take some of the
Because-
natural numbers, like from 1 to 8, and we can just find that there is
That
because
does not guarantee that it is true for all.
Because
You take
natural
an
Sir, we
numbers
can
of
gen-
2n or n by 2.
Sir, it is a
So
countable.
when we solving the okay, sorry.
because
go
the
ahead.
natural number is containing odd and even both,
Okay.
all the output
And-
generated are
and
fall
codomain is
into
also natural
natural
number,
number.
and the range is also a natural number. So it is
And
codomain.
range is natural number. Why? That is my question. Why
Sir,
range
whenever
is the
we
whole
are-
natural
Sir,
number?
because
Yeah. The all because it's contain the all natural numbers.
One by one. When someone is, you are seeing that someone is talking and you are also talking, then you should understand that I cannot hear anyone, right?
when odd number put in taken, then it gives even number.
When
And
odd
when
number
even
is,
number taken,
yeah,
then
right,
odd
it is
number
giving even number. Then, and how we are getting the odd numbers?
when
Sir,
even
we
number is taken.
Through n
odd
by 2, sir.
Right. So basically, two types of number are possible, right? So if we take the codomain, there are natural numbers. So two types of number are possible, either even or odd, right? Either the number of the form 2k or 2k plus 1. These two cases are possible, correct?
Yes,
Yes,
So
sir.
if you can find the p-image for both these, then we are done, right? Now how these 2k form numbers are coming?
From the 2n.
Both
From the 2n portion.
even. Yeah,
Take any
Yes, sir.
k which may be odd. I mean, k, if it is odd, then obviously it is of the form 2n, or if it is even, then we go to this case and we'll take that. But take any k like this, so we'll get all the form from this, from all the even number from this, right? 1, 3, 5, take anything, all the even numbers, whatever the even numbers are, we'll get by this definition, correct?
Yes, sir.
Now how we'll get the odd number?
N by 2.
n by 2.
By doing this, right?
Yes,
We
sir.
just take the product of this 2k plus 1. This one.
Yes, sir.
This is an even number, correct?
Yes, sir.
Right?
No, this is
If you
this is
give
the
this
odd.
as an input,
Yes.
if you give this as an input, f of this, what will be that? 2 into 2k plus 1 by 2, then we get that odd number.
Yes, sir.
Is it clear? So this is the proof. Whatever the odd number you want to get, that should be of the form 2k plus 1. Is it clear to everyone?
Sir, can you please explain the odd proof?
That is what I am doing. If any odd number, so any odd number can be expressed by 2k plus 1. Is it clear to everyone?
Yes, sir.
For some k. Now I want to get this as my output. What should be my input? I am saying your input should be 2 into 2k plus 1. First of all, 2 into 2k plus 1. This is even, correct? Multiple of 2. 2 into
Yes,
something. So it is
yes,
even.
sir.
So if I take f of this, which definition should I take? If n is even, then this definition should work. Right? So
Yes,
2
yes, sir.
into 2k plus 1 by 2.
Divided by 2. Yes, sir.
This will cancel out. So I am getting 2k
Now
plus
we
1
get
as my
odd number.
image.
Yes, sir.
So this pre-image of 2k plus 1 is basically 2 into 2k plus 1. That's how we get all the odd number. Clear?
Yes, sir.
Yes.
So this function is
Yes, sir.
clearly onto. So onto, but not one to one.
If the range is R to R, then the is same.
Then odd even, how can you define? No?
Right.
Odd even can be defined only for natural number, right?
Right. So
Is it clear to everyone?
Yes, sir.
Yes.
Yes, sir.
Okay. So whatever we have discussed today, is it clear to? I think so. We have defined. We have discussed many different type of problem today, right? And
this is the best class, sir.
hope it is clear.
Sir, I was having one doubt.
Yeah.
So how can a bijection be useful for measuring the cardinality?
This is little bit of deep question. So have you seen the last 3 lecture which is not in the syllabus? And there is a lecture called Infinity, Understanding Infinity.
Yes,
Have
sir.
you seen that?
So that are
So
not in a
basically,
syllabus.
what that is not in the syllabus. The last these lectures. Let me see whether that is there or not now.
These are
Yeah,
all
degree of infinity. This one. Have you seen
One-to-one
this lecture?
correspondence. Actually, there is.
Basically, bijection give one-to-one correspondence. So when I mean, we don't have any counting system. People used to live in caves, maybe. Okay, so at that time they also have their sheeps, right? Herd of sheeps with them. Now, how they keep count, right? So what they used to do, basically, they have some pebbles with them, small pebbles. Okay. Now they have some sheeps.
I understood this example, sir. Professor Madhav has given this example. I understood, but I am not able to relate this to the to my question.
So suppose 1, 2, 3, 4, 5. These are natural number, right? Some subset of natural number, correct?
Right, sir.
Okay. Now suppose you have a set. Okay. There are 5 elements. Basically, if you understand this example, then this should be more clear. This is your set, correct?
Right, sir.
Now, if I have a bijection from this set to this set, bijection means it is both one to one and onto, right? Every element has a pre-image, correct?
Right, sir.
And no two elements are going to the same one. So for each one of these, there is one element of A. Now, these two have same cardinality, correct?
Right, sir.
That is what bijection does.
But
so it is
this is
quite
also
visible
possible for injective function. Will also
no, that is the issue. I mean, it is quite trivial for finite set, but when you go to infinite set, these become more, I mean, influenceable maybe. Right? For finite, it is quite clear. We only need injectivity, what you are saying. But for infinite set, there are some issue. So I will tell you, like, suppose how you can prove the set of even number and odd number are same cardinality. Can you prove that? Set of even number.
Sir.
Suppose A is set of even number and B is set of odd number. How you can show that they have same cardinality?
It is somewhat tricky, sir.
But we can show it directly. So any even number is basically of the form 2n, right? Where n is natural number. Just now I have said, and this is 2n plus 1. Right? Correct?
Right, sir.
So what I can do is take F. So A to B, or say B to A, B to A. Let's define B to A. This is odd number, right? Any k. You define is 2k. Correct?
Right, sir.
So what you are doing here? So 1 you will get 2. For 2 you get 4. For each natural number, odd natural number, you are getting some image here, or maybe 2k. because I should get some zero from somewhere, but that I can discuss later. But at least you can understand for each element. I mean, there is a correspondent. 1 is going to 2, 2 is going to 4, 3 is going to 6, like this, right?
Right.
Now
Sir.
this function is both 1, 1 and on 2. This is a bijection, correct? So all this set is equal to all this. I mean, the coordinate of these two sets are equal. Can you see that?
Yes, sir.
Yeah. Now, if I tell you that these two sets, coordinate of A and coordinate of B are same, and this is same as the coordinate of natural number, will you believe that? They are subset, right? But I am saying their coordinate are same. That is the fun with set of infinity. I mean, infinite set. This is set of natural number.
So, but their cardinality should be half.
No, that is not. That is the fun. Their coordinate is same as the set of natural number. That
Because
we
it
can
is
show.
R to
Because
R.
there is a bijection. Huh?
Because this function is R to R.
R to R. No, function. I can define a function from N to A so that this is a bijection. I can define a function like this.
N to N.
X plus 1.
N to A, which is a bijection. I can define a function like this. Okay. And when I can define a function like this, there is bijection means
What is A, sir?
set of even numbers.
Oh, okay.
I can define a function like this. Okay.
Yes, sir.
Which is a bijection. And as I can define this, this is the coordinate of these two are same. So I don't want to go there because this is not in the syllabus and many of you will get more confused. So those who are interested in this, they can ask me separately. I will tell you in separate session. Will that be okay?
Yes.
This is really interesting, but this is only important for those who want to know more about this.
Sir, I have a doubt,
I
sir.
don't want to. Yeah.
Sir, do we have any extra questions, sir? Or question is ended?
No. My session is over.
Okay. Thank you.
My session
Sir,
is
I
over.
have a
Yeah.
doubt, sir.
Yeah.
It is on transitive relation, sir.
Okay.
So let's say a set X has elements A, B, C, D, and E.
Okay.
And A is defined on X cross X. Okay.
Let me write it.
Yes, sir.
Yeah.
And A is defined on X cross X.
Okay.
So
how it is defined?
A has elements like A comma B and B comma C and A comma C and B comma D and D comma E. That's it.
Okay.
So is this a transitive relationship, sir?
You tell me.
No. Half of the elements are first three elements are
If
showing that.
AB and BC are there, then AC is there. That is fine. But BD and DE are there, but BE is not there.
E is not.
So it is not transitive, right? Because BE should be there to be transitive. Correct?
Yes, sir.
Not transitive.
So if a tuple is only one element in a set, it is by itself transitive, right?
Yes. Because we don't have to check for the other condition.
Okay.
Correct. Yeah.
Okay, sir. And sir, can you? I think those last 4 videos are out of the syllabus, right?
Last 4, not last 4. I think 3. No.
Sir, 4.
There are 4 videos.
4. Prime number, natural. 4 videos.
These are out of syllabus, right, sir?
Yeah. These,
So
if you are interested to learn those, you can see those. Otherwise, ignore this.
Yes, sir. All of the lectures, I have some confusion in some of them.
So if you are interested, we can talk later about this. But for now, you.
Okay, sir. Thank you, sir.
So I had a question.
Sir.
Okay. Yeah.
Sir, I have a doubt in question number 8.
Which question number 8?
Sir, slide question number 8.
Oh, okay.
Sir, in even condition, if we put if we put n by 2 in one condition, 1 by 2, then we get 1 by 2 also.
No,
So,
that is only applicable for n is even.
Yes, sir.
Is one even?
No, sir. No, sir.
Understood, no?
Yes, sir. Now understand.
Okay,
Thank you,
great.
sir.
Yeah.
Sir,
Yeah.
sir, please provide the solution of that assignment, practice
Which
assignment
assignment?
question.
It should be uploaded in the portal. Is it not uploaded yet?
No, sir.
Okay, okay. I will
No,
tell.
sir.
I will
Sir,
tell
may
the
I ask a
upload.
question from activity question?
Why don't you try yourself now? You understood all the concept, right?
Sir, I have doubt in graph which you represent in today's session.
Which graph?
You explain, sir.
Mod X.
Yes, sir. Fx is
Okay.
equal to mod x plus 4 question in above slide.
Yeah. This one, right?
Yes, sir. Sir, I want to know how you represent this. Fx is equal to mod x. So we started it from origin and range go above. Okay. And in next fx is equal to x plus 4. So how we started from minus 4, sir?
So when it intersect the x-axis, intersect the x-axis means this should be 0. Mod of x plus 4 should be 0.
Okay.
Right?
Okay.
When mod of x plus 4 is 0?
When it is minus 4.
X is minus 4. That
X
is
is
what.
minus. Oh.
So this is minus 4 comma 0. Now everything is positive, right? From
Okay,
here
sir.
it is like this. From here it is like this.
Okay, sir.
Okay.
Okay, sir. Thank you.
Sir, I have a question.
Anyway, we will do this graph later when we will do calculus. So for the first portion, till this much understanding is enough. But we will understand these graphs in details when we come to calculus portion.
So I had a small doubt.
Okay.
So it's not like related to any question, but so it's about closed and open intervals and sets.
Okay.
So what about infinity? Do we usually use?
No, infinity is open, always open.
It's open.
Infinity is not a number.
Yes. Okay. Okay.
Infinity is
That's
not
it.
a number. Right? Yeah.
Sir, I have a question, sir, from the practice assignment. So
Okay.
there was a set is that contains all the name of the months, and
you have to write down that thing. That will be a little bit lengthy process.
that is so
but
tedious, sir. It
that
R3
is
will
very
contain
tedious,
8.
I understand.
R3
that is
will
very
contain
tedious.
85 number.
I know that. This is very tedious. I will not do this in live session.
Sir, are you going to take the next open session?
So, sir, my question is there any?
When is the next open session? I don't remember.
This week only. I think day after tomorrow, I
I
guess.
have a session this week, but I am also taking the maths 2 session. So I am not sure whether I am taking the next maths 1 live
Because sir, in every class, somebody asks the same question and no teacher is doing the detailed solution for this, So we really
Which
want
one?
somebody to, this the same question which the other guy asked.
No, this solution will be uploaded, no?
Sir, I know it is uploaded and I have gone through mental. I think the last
Yes,
relation
sir.
I want to understand.
So actually, my question was: is there any easy way to do this or not?
No.
Sir, I want to understand R3 actually.
What is cardinality of R3? Same question.
Okay. Yeah, basically it's question number 13 you are asking. Okay, so let me see.
So will these kind of tedious questions be in the quiz?
No. This is just for practice. This will not come anyway. So R3, what R3 is saying? R3 is saying all those pairs for which the first pair, that A comma B, should be in R1 and the second pair, B comma C, should be in R2. We take all such pair and take A comma C in R3, right? Suppose what is R1? First of all, tell me what is R1. Can you tell me what is
Sir,
R1?
all the months except May.
Same last 4 letters, not all the month. I mean, what are the pairs?
Sir, the same month will also be there, and also we can say like January, February, and then September, November,
So
November,
there will be
December.
some classes, right?
Yeah.
So if you write this,
it will be, sir, January, Feb, Jan, September,
January,
November.
February, March, April, May, June, July. So January, February, this will together give 4 elements, right?
Yes, sir.
Correct? Have you understood why I am doing this?
Yes, sir.
Yes, sir.
That's why I said except May, every month will repeat with itself.
No, January cannot be with September, right?
No, I'm saying every month will repeat with itself, means January, February, except May, because May has only 3 letters.
Fine. What are other? Can you
It
tell
will be
me?
reflexive function, reflexive relation.
September, November, and December.
September, November.
September, December.
September, November, December. Yeah, both.
Say these 3 will come together, right?
Yes, sir.
September, November.
Sir, why
So
it
all
will
this
come
will
3,
come
sir?
there, right?
It will. Oh, so yes, sir. I thought you are saying that it will come, a triple will come. So
No.
No, they
So
group.
all this
They
will be
make the
there,
there
right?
will be
group.
6
This is
pairs, right?
something.
From those 3, September, November, and December.
8 pairs.
8 pairs.
3 plus 3. How, sir? I thought it will be September.
No, this will September will be there.
Yes, sir.
Right? September, December will be there. Then
sorry, sir. 9. Sorry, 9.
3 is a 9, sir. September, November,
9 will
and
be there,
December.
right?
9 will be
will
there,
be
sir.
there.
Sorry, sir. 9 will
So
be
9
there.
will be there, right? Now in R2, can something which are in R2, can you tell me something? Which are in R2? R2 is AB, same number of days, right?
Yes, sir.
So again, Jan will be there. January, March will be there, right? Okay. Now,
January, May.
but I only need this to give you what R3 is. So R3 is what? R3 is basically A comma C, right? It is written as A comma C, such that AB is R1 and BC is in R2, right?
The transitive
AB
part.
is in R1, not transitive, it is coming from 2 different set. And BC is in R2, right?
Yes, sir.
So basically, here if you see February, Jan is in R1, right? And here January and March is in R2, right? Correct? So in R3 there is an element like February, March. This is in R3. This will come in R3. Is it clear?
Yes.
Okay, sir. Yeah.
So only those elements which are starting in R2, starting with this Jan, February, September, December, November, like this. All these elements which are starting in R2. Only for those pair, the element from R1 and R2 combined will come to R3. Okay, this is again I am saying this is not a small way I am saying. This is a tedious way, but that's how this definition is working at least. That you can understand, right?
Yeah, it's clear, sir. We can do now.
Okay, so that question was here.
Yeah.
Sir, I have a general doubt.
Only for the practice.
Only for the practice, and this is really tedious. I understand. You can do calculation, Mr. That also I can understand. So nothing worry about that. This type of question will not come.
Yeah. Thank you, sir.
Okay. This is only for practice. Yeah.
Sir, sir, will the slides of solve with instructor will be provided to us?
Yeah, I will upload it in the portal.
Okay. So where I can find the practice assignment solution?
It will be uploaded in the what it's called. I think it is uploaded in the solution section. There is a solution section, no?
No.
It will be uploaded. Supplementary contents. Under supplementary content, there will be solution, and there it will be uploaded. Okay.
Okay. Thank you, sir.
Excuse me, sir. I just have a very small doubt, very fundamental doubt. It's about sets. So if we say phi is an empty set, right?
Okay.
5. So let us say if I'm going to write that as 5 is equal to open curly brace and close curly brace. Does that mean that 5 is, does it represent an empty set? Or
yeah,
because I know 5 we call an empty set as 5, but can I say 5 is equal to open curly brace and close curly brace? Is that notation right?
Correct. The notation is correct.
Oh, all right. Thank you.
Okay.
Thank you. Thank you.
Sir, I have a question. So can you like solve it?
Which question?
There is a question that we have to find the range, and the question is f of x is equal to x upon 1 plus x square.
Where have you got this?
Sir, I have some resources, so like I'm solving from there.
Tell me what is the.
So we have to find the range.
Tell me how you can find this range.
Like we will substitute the f of x to y.
What? Yeah, if you substitute f of x equal to y, then first of all, can you tell me what is the range of this one?
Greater than equal to 0.
Greater than equal to 1.
0.
Greater than equal to 0 or 1?
0,
sir.
1, sir. 1, sir.
1.
1, sir.
0
X
can
square
never
is greater
come
than
now.
0, no? X square
It
should
will
be
never
always
be
greater
0.
than 0. So it is greater than equal to 1, right?
Okay, sir.
Who was asking this question? Where is he? Who asked this question?
Yes, sir. Sir,
yeah,
me.
why are not you answering this? I want to answer from you, right? So have you understood that f(x) equal to 1 plus x square, what is the range of this function?
Sir, it will be like 1.
Range is just 1. Why don't you go back and read what range is and whatever throughout the session I have explained, and then come back and ask this? Is that
Okay, sir. Okay,
because
sir.
you have many gap understanding in range itself now, right?
Okay, sir.
So first you clarify that, then we will solve this problem. This problem is not very difficult. I think you yourself can solve this, but before that you understand what this basic function 1 plus x square, what is the range of it. Now then you see what is the range of this function. Next ask what is the range of this function, and then you come to this function. Is that okay? If you can find the range of these three functions, then I think you will find the function of this function, range of this function. Okay, I am giving you a hint.
Sir, I have
the
one.
range of these three functions is quite clear from the equation. Okay.
So
yeah.
Yeah. So can a null set can we like investigate about reflexivity, transitivity on null set?
I mean, null set does not have any element, right? So null set is a set. First of
So
all,
it is not reflexive, it is not transitive, and it's not symmetric, right?
No, first of all, a set is not reflexive, transitive or not. First of all, what is the relation on that? You have to define a relation on null set first. Then you can ask whether the relation is reflexive, transitive or that thing, right?
Okay. So, okay, fine.
But if there are no element in a relation, I think you are asking that. If
actually, I'm relating null set to null set.
I understood that. But if there are no element to check, then by default you can say everything is satisfied, right? That is vacuously true. If you remember, remember this term.
But sir, we can also say that there
sir.
is no relation between them because they both are null.
Sir, it is not reflexive for sure, but I don't recall it. But it is not reflexive.
Why? Reflexive means there should be some element, right?
Yes.
Because that's why we don't actually bother about talking relation on null set. Because there are no element to compare with. So one thing we can say, this is vacuously true for everything. We can take this as a definition that everything is vacuously true. We can take it reflexive, symmetric, equivalent, or we can take nothing is happening. That also we can take as definition. right? So all these are depending on the definition and the axiom which we are working with, right? This is depending on us on which we want to work with. Okay.
Sir, I have a question
zero
in
is a natural
this.
number or not, that depends on the axiom you are choosing. So in computer science, 0 we take as in natural number, but in math we don't take 0 in natural number. Right? But for this course we are taking 0 in natural number. So it depends on the axiom you are talking about. So similarly for null set also, if you are concerned about the relation on that, you should focus on the axiom which we are working with. Okay.
But sir, I have a question. Like, if there is no element in that, then how can we say that there is any relation in
that
between?
Is what I am saying. This depends on the axiom which you are working, you want to work with. Right?
Yes. Okay.
First of all, are you defining relation on an empty set? That is the first question you are asking.
So that's what I'm
Are
saying.
we
We cannot
defining a
define, no? We cannot define. Can we define?
Someone say, okay, I define that, I take a relation on empty set, I define that as an equivalent relation. I take that. I take that as my axiom. I can choose that. No? There is no proof for that. And if logically it is not argumenting with any other thing, then it is fine. The example I am giving you, 0 natural number or not. So computer scientists say 0 is a natural number, mathematicians say 0 is not a natural number. That does not hold back any mathematics altogether. So both of them are valid on their own field. So this is called axiom, what you are choosing to be true and which is logically does not flaw in any theorem of your upcoming mathematical logic. That is what this is. Okay.
Sir, I'm having a doubt.
I think we should stop the session now, and can we take this out in the next session?
Okay, sir, because it's related to the activity. So I thought before attending the graded assignment, it would be useful.
Graded assignment deadline is extended, I think, no?
Is it 5th, sir? Because the mail said it was 3rd.
No, it is extended now.
Okay, thank you, sir.
Okay, so I think I will close the session now. Okay.
Sir, one generic question. Sir, one generic question. Regarding the extension, will the next week 2 assignment will also be postponed, or the dates
No.
stay
I
same?
think week 1 and week 2 have the same deadline now. No.
No, it is 8th.
So
For week 2, it is 8th.
Yes, sir.
Week 2, it is 8th.
For week 1, it is 5th February.
Week 1 is 5th and week 2nd is 8th.
Okay. No, week 2 will not be extended. Okay. Because for week 1, there are some technical issue at the beginning. That's why it is extended.
Sir, where I can find the questions that you have posed today? Where
I will
can
upload it
download
in the
this?
portal. I will upload it. Okay.
Sir, I have
Yeah.
to just clear one thing from assignment 1.8.
Okay.
Sir, it's in 7th question. Can you please explain 2nd and 3rd point? I'm just confused in it.
Activity 1.8.
Yes, sir.
7th question.
7th question, 2nd and 3rd point. Just explain me, like, how is it?
Today I have explained it. Go through this session.
Okay.
Okay. Today I have explained this. Both of this.
Yes, sir.
Okay.
Will qualify contain the questions from this assignment only, or different?
Same question will not come, but question on same concept will definitely come. Right? These are the concepts. These are the topics you understand. You have to clarify your concept, and on those concept question will come. But I guarantee you, none of the question from these exactly same question will not come. Okay, you cannot expect that, right? Exactly same question will come, right?
Yes, thank you.
Yeah. Okay, I think we can stop the session now, right?
Yes, sir. Thank you, sir, so much, sir. It was productive.
Thank you so much, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir. Thank you.
Thank you, sir.
Yeah, it's a good class.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.